Your agent sees a README, runs pip install, and your API tokens ride along. One line can quietly walk them out. So why does the same model stop it in one tool but ship it in another? Agents read docs and act fast, but they don't verify who sent the package, what the real name is, or if the pinned version is booby-trapped. That's the opening attackers use, and the obvious fix, use a smarter model, keeps missing the real failure point. The authors name the hole, a gap between a package mentioned in text and code running on your machine. The README becomes a delivery truck, and nobody scans it at the gate. So imagine an airport X-ray at the gate. Pause the belt before anything boards, light up the label, the sender, and the contents, and only then wave it through. Sounds obvious, but how do you wire that into an agent that just wants to run? Here's the trick: a deterministic pre-install gate, about 400 lines, that runs before any code executes. It verifies names, verifies sources, checks versions for known CVEs, expands hidden directives, and blocks unknown registries by default. Bad boxes get kicked, clean ones glide. Does it hold up? The same model flips outcomes when you swap harnesses. Version pins sail through everywhere, and the gate blocks most targeted attacks regardless of model tier. In practice, treat extra index URL and friends as high signal, expand R to expose hidden directives, sandbox installs with minimal creds, and make post install reviews a default, because some misses turn into catches when you ask. A flag is not a defense, an X-ray at the gate is. Scan before you install, then let your agent fly. If you build or run agents, add the X-ray. For more research turned into working practice, follow AI Admirals.